Hello everyone, good evening. So here we shall solve some more JEE Mains previous year questions on the chapter Laws of Motion. So any doubts if you have in any steps, then please write that in the comments section. We shall obviously clarify them in the subsequent videos. Also in any other chapter of physics, if you have more difficulty, then please mention the name of that chapter also in the comments. We shall obviously so that we can give more priority on it and solve more and more questions on that chapter. Also, some important homework questions will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. So here it is told a system of two blocks of masses 2 kg and 8 kg is placed on the, so this is 8 kg and this is 2 kg, is placed on a smooth table. So the table is smooth, has no friction. The coefficient of static friction between two blocks, mu s, that is 0.5. The maximum horizontal force that can be applied to the block of mass m so that the blocks move together will be. So when maximum horizontal force is applied, then maximum static friction should act. So then if we draw the free body diagram of the mass capital M, then here we will have mg, here we will have normal reaction, and the normal reaction of the ground will also act upwards, that is n1 suppose, and this is F, and here we will have friction Fs, the static friction. Okay. And then if you draw the free body diagram of the mass small m, then that is the weight is mg, which is acting downwards, and the normal reaction n is acting upwards, and frictional force that will act forwards here, Fs. And they will have some common acceleration a. They will move together with the common acceleration, since maximum horizontal force should act, so maximum static friction force will act. So here the maximum static friction force will act, so it means we know that Fs max, that is given as mu s into n. So here we can see n will be equal to mg, and here it is accelerating towards the right. So therefore Fs, that is mu s mg, that is equal to m into a. And this here we can see that n plus mg, that is equal to n1, and f minus fs max, that is equal to m into a. So therefore f minus fs max, that is mu s mg, that is equal to ma. So fs max is equal to ma, fs max equal to ma. Now therefore from here we can say acceleration, that is equal to mu s into g. So therefore f will be equal to mu s mg plus ma, m into mu s into g. So this will be mu s into g into m plus m. So therefore the maximum force that should be applied, that can be applied, that will be mu s, that is 0.5 into g. G is 10, no, g is 9.8 into m plus m, that is 10. So this will be 5 into 9.8 Newton. So which will be 5 at the 40, 5 at the 45, so it is 49 Newton. So 49 Newton is the maximum horizontal force that can be applied to the block of mass m so that the blocks move together. So option C is the correct answer. Then it is told a person is standing in an elevator in which situation he experiences weight loss. So here when he is suppose standing on the floor of the elevator, so when he experiences weight loss, so when the elevator is accelerating downwards with some acceleration a, then the normal reaction is acting on him upwards and his own weight is acting downward. So here we can say mg minus n, that will be equal to m into a, if m is the mass of that person. So here n will be equal to m into g minus a. So here actually it is the normal reaction which is actually the apparent weight, which he will experience. So the apparent weight is actually, it is coming less than mg, which is less than the weight, l- less than his actual weight. So here in this case he will experience weight loss. So it means when the elevator moves downward with constant acceleration, and when it is moving upward with constant acceleration, then we will say n minus mg equal to ma. So here actually n will come m into g plus a, so which will be more than mg. So here he will experience some weight gain. And when the elevator is moving upward or downward with uniform velocity, it means the acceleration is 0. So here he will experience neither weight loss nor weight gain. Since why here acceleration is 0 only, so we can say n will be equal to mg. So the apparent weight will be same as the actual weight only. So option B is the correct answer, since if the elevator moves downward with constant acceleration, then only he will experience weight loss. Then here it is told an object of mass m is thrown vertically upwards from the ground. 5 kg mass, it is thrown upwards from the ground. Then the air resistance produces a constant retarding force. The air resistance produces a constant retarding force 10 Newton throughout the motion. motion. The ratio of time of ascent to the time of descent will be. So the retarding force, it is always acting opposite to the velocity of the object. So suppose it is thrown upwards with a initial velocity u. Then here the retarding force when it is going upwards, it is mg. Retarding force is mg plus the 10 Newton. Its weight is 5 kg. So g we can take 10 meter per second square. So the weight, that is 50 plus 10, that is 60 Newton. 60 Newton. 60 Newton force, that is the retarding force. So 60 by 5, that will give us the retardation, that is minus 12 meter per second square. So therefore we can say that V, that is 0 when it will reach the uppermost point. So V equal to u plus et. So therefore here we will say V, that is 0 equal to u minus 12 into t. So it means the time of ascent, that will be equal to u by 12 seconds. So this is the time of ascent, and for time of descent, we have to find when it is coming down. So here we can find how much distance it will go upwards. That is equal to v square, that is equal to u square minus 2as 2a into h. Till how much height it will go, we can find out. So therefore h will be equal to u square by 24. So then when it will come downwards, then we can say this h will be equal to half gt square, half into 10 into td square, with that where td is the time of descent. Since when it is coming down, then the initial velocity will be 0 only, which is the velocity at the uppermost point where it will reach. So then 2 5s are 10. So td square, that is coming equal to h by 5. So h will be u square by 24 into 5. So therefore td, that is equal to u square by 5 for the 20, 5 to 10, 120. So therefore td, that will be equal to u by is 120, that is actually 2 6 are 12, 2 30, and 2 15, 15. So this is 2 root 30, u by 2 root 30. This is the time of descent. Therefore we have to find the ratio of time of ascent to the time of descent. So therefore ta by td, that we have to find out. So ta, that is u by 12, and td, that is u by 2 root 30. So it means u and u will get cancelled. So then therefore 2 root 30 by 12. So then 2 6 12. So this will be root over 5 into root over 6. I can say 5 6 are 30, and this 6 also you can say root 6 into root 6. So root 6 will cancel. So this is root 5 is to root 6. But here it is not the option. V equal to u plus t. So acceleration, that is, no, here when it is coming downwards, then the retarding force is acting upwards. Retarding force is acting upwards. So the retarding force, that is 10 Newton. Then and downwards it is 50 Newton. So the net force acting downwards, that is 40 Newton. So therefore the retardation a dash, when it is when the acceleration when it is coming downwards, that will be 40 force by mass. So it is 8 meter per second square. So therefore h will be u square by 24 only. This h will be equal to half a is 8. This is wrong actually. It is actually half into a at square. The acceleration when it is coming down, this is 50 downwards, 50 Newton is downwards, and 10 Newton is upwards. So then half into 8 into t square, so 2 4 is 8. So td square, that is equal to h by 4. So h is u square by 24 into 4. So therefore td, that will be equal to u by 4 6 24. So I can say 4 into root 6. 4 root 6. Okay, u by 4 root 6. So this is not correct. So therefore we have to find u square t a by td. That is equal to time of ascent to time of descent, this ratio. So TA is u by 12 and TD is u by 4 root 6. So this will be equal to 4 root 6 by 12. So 4 3 is a 12. So then root 6 is root 2 into root 3. And then 3 is root 3 into root 3. So root 3 will get cancelled. So the required ratio is root 2 is to root 3. So option B is the correct answer. Then here it is told a block of mass 10 kg starts sliding on a surface. With an initial velocity u, which is 9.8 meter per second. The coefficient of friction in between the surface and the block is 0.5. The distance covered by the block before coming to rest. So before it comes to rest, it means that finally it will come to rest v equal to 0. Then how much uh, uh, distance it will cover, that is x, that we have to find out. So the coefficient of friction is this, and here normal reaction is acting that is mg, and normal reaction is acting upwards, which is n, and its weight is acting mg. So n will be equal to mg, and then therefore the frictional force that will be equal to mu times n. So that is mu into mg. So now therefore so here the frictional force is acting as the retarding force. Frictional force is acting as the retarding force. So now we can say v square equal to u square plus 2as. So now this displacement is x and v is 0. So 0 square equal to u square minus 2 into the frictional force, that is equal to friction equal to mu ma. So therefore acceleration is mu g. So the acceleration is mu g, 2 into mu g into x. So x we have to find out. X will be equal to u square by 2 mu g. So u is 9.8 into 9.8 divided by 2 into mu. Mu is equal to 0.5 into g. G is also 9.8. So 2 into 0.5, that is 1. So it is 9.8 meters. So the block will cover a distance of 9.8 meters on the surface before coming to rest. So option B is the correct answer. Then here it is told that four forces are acting at a point P. Four forces are acting at a point P in equilibrium as shown in figure. The ratio of force F1 to F2. The ratio of the force F1 to F2 is 1:x, where x is. So the point P is in equilibrium. Then we can take x and y components. Now This will be 2 cos 45 plus 1 cos 45. And this way it will be 1 cos 45, or you can say 1 sin 45. And then here also this component will be this is 2 sin 45 actually. So it is in equilibrium. Therefore, I can say f1 should be f1 plus sin 45, that is 1 by root 2, that should be equal to 2 sin 45, 2 by root 2. So therefore, the force f1, that will be equal to 1 plus 1 by root 2, that is equal to 2 by root 2. So that is 2 by root 2 minus 1 by root 2, that is equal to 1 by root 2. Then f2 will be equal to 2 cos 45 is 1 by root 2 plus cos 45, which is 1 by root 2. So which is 3 by root 2. So now the ratio of f1 is to f2 is 1 is to x, where x is how much? So now it is told f1 is to f2, that will be equal to 1 is to x. So now f1 is 1 by root 2 is to f2 is 3 by root 2, that is equal to 1 is to x. So root 2 and root 2 will get cancelled, therefore we will get x as 3. So x will be equal to 3. 3 is the answer. Then here it is told a hanging mass m is connected to 4 times bigger mass by using a string pulley arrangement as shown in the figure. The bigger mass is placed on a horizontal ice slab and being pulled by 2 mg force. In this situation, the tension in the string that is equal to x by 5 mg, for x equal to how much? X should be how much? The tension is x by 5 mg for x equal to how much? And then it is told neglect mass of the string and friction of the block with the ice slab. So here actually we have to find how much is the tension force. So if you draw the free body diagram of this mass m, then upward we have tension, and here we have its weight, that is mg. Means here the force is higher, so there will be acceleration towards the left for this string mass system. So here we have tension, so I can say 2 mg minus t, that is equal to 4 ma. And we can say here actually 4 mg is acting, and here and friction is not there. Friction is not there. This is the normal reaction n. So therefore n will be equal to 4 mg. N will be equal to 4 mg, but it has no use, since I can say 2 mg minus t, that is equal to 4 ma, and mg but here for this one it will be t minus mg, that is equal to Now if we add them, then T will get cancelled, then we will get mg equal to 5 ma. For acceleration is mg by 5. Sorry, equal to 5 ma. Mg equal to 5 ma. So m will cancel out. So A will be equal to g by 5. So the acceleration is g by 5. So therefore T we can find out. T will be ma, that is mg by 3. T will be equal to mg by 3 plus mg. So this will be equal to mg into 1 plus 1 by 3, which is 4 by 3. So it is 4 by 3 mg. So therefore the tension is, sorry, acceleration is g by 5, not g by 3. So it is ma plus mg. A is g by 5 plus mg. It is 1 plus 1 by 5. That is mg into 1 plus 1 by 5. That is 6 by 5. So this tension force equal to 6 by 5 mg. So therefore x should be equal to 6. X will be equal to 6. Here it is told a mass of 10 kg is suspended vertically by a rope. Mass of 10 kg is suspended vertically by a rope of length 5 meter from the roof. This mass is m, that is 10 kg, that is suspended vertically by a rope of length 5 meter from the roof. Now a force of 30 Newton is applied at the middle point of the rope. Force of 30 Newton is applied at the middle point of the rope. Here 30 Newton force is applied in the horizontal direction. The angle made by upper half of the rope with vertical is. So if it is pulled like this, then what will happen, that the upper part, the upper half will make some angle like this. The upper half will make some angle. This length is 5 meters, so each part length is 2.5 meters. 2.5. Force of this is applied. Then what is the angle theta that is made by the upper half of the rope with the vertical, that you have to find out. And if that theta that is given as tan inverse of x by 10, tan inverse of x by 10, then the value of x is how much, that you have to find out. Now here we can see that this is the tension force. This way we have the tension force, and here force 50 Newton, and here mg is acting mg. Now if this is theta, then this is also angle theta only. Then here we will have t cos theta, and here we will have t sin theta. So therefore, since the mass is in equilibrium, the mass is in equilibrium, so we can say that t sin theta, that should be equal to f, and the mass is also in equilibrium, and the rope is also in equilibrium. Rope is also in equilibrium. So simply we can say that t sin theta will be equal to f, and this t cos theta, that will be equal to mg. Now if we divide these two equations, then we will get tan theta, that is equal to f by mg. Tan theta, that is 30 is 30 by mg, that is 10 into 10, that is 100. So it is 3 by 10. So theta will be tan inverse of 3 by 10. So it means x should be equal to 3. So the value of x is 3. Okay, so here it is told that a system of 10 balls each of mass 2 kg are connected via massless and unstretchable string. The system is allowed to slip unstretchable string. The system is allowed to slip over the edge of a smooth table as shown in figure. Tension on the string between the 7th and the 8th ball is is dash Newton when 6th ball just leaves the table. So here so when the 6th ball, so there are 10 balls, 3 plus 4 7 plus 3 10. So when the 6th ball just leaves the table, it will be like this. So it means here we will have 6 balls, first, second, third, fourth, fifth, sixth, and then here we will have the 7th ball, 8th ball, 9th ball, and the 10th ball. So then their masses are same, m. Their mass of each ball is 2 kg. The tension in the string in between the 7th and the 8th ball is. So here the net mass, it is 6 mg, is downward. So if we draw its free body diagram of these 6 balls, then this is 6 mg downwards, and here we have a tension force, let's say T1. So this is the 7th ball, this is the 8th ball, and the 7th ball, here we have, let's say, here we will have T1. This is the same string, so here T1 force, and the system will move with the same acceleration a, since uh, they are since the string is unstretchable, and here the tension is T2, and there is no friction. It is a smooth table, it has been told. So now the 8th ball, so we have to draw the free body diagram of the remaining 3 balls. So here we will have T2, So therefore it is moving with acceleration a. Their mass is m. Its mass is m. It is moving with acceleration a. So here we can say this, that it is moving with acceleration a. So 6 mg minus t1, that is equal to 6 ma. And similarly t1 minus t2, that is equal to ma, and t2, that is will be equal to 3 ma. And here it is asked to find out t2, which is the tension on the string in between the seventh and the eighth ball. Since why this is the eighth ball and this is the seventh ball. So therefore now if we add all these, then we will get t2 will cancel, t1 will cancel. So then we will get 6 mg, that is equal to 3 plus 1 4, 4 plus 6 10 is equal to 10 ma. 6 mg equal to 10 ma. So therefore will cancel, then a will be equal to 6g by 10. 6g by 10. So now therefore t2 we have to find. Therefore the tension t2, that will be equal to 3 ma. That is equal to 3m into 6g by 10. Now this will be equal to 6 into 3 into mass is 2 kg into 6 into g is 10 by 10. So 10 and 10 will cancel. So this is equal to 6, 3 is 6, 6, 6 is 36 Newton. So 36 Newton is the answer. 36 is the answer. Okay. Then here it is told a block of mass 200 gram is kept stationary on a smooth inclined plane by applying a minimum horizontal force F equal to root x Newton as shown in figure. The value of x is, so here the mass is m, that is 200 gram. M is equal to 0.2 kg. Now mg is acting vertically downwards and force is acting, F is acting horizontally. So now some component, so let's say this is angle theta, which is 60 degrees. So this will be angle theta also. So we can say this is mg cos theta, and similarly this will be theta also. So this will be f cos theta, and this way it will be f sin theta. And here normal reaction will act, which is normal to the surface. Now it is kept stationary on a smooth inclined plane. And here mg sin theta is also acting. So there is no frictional force. So now therefore we can say that f cos theta, that should be equal to mg sin theta. Then only it will be kept at rest. So now f, that is root x into cos theta, that is equal to mgm is 0.2 into g, that is 10 into sine theta. Theta is 60 degree. Now root x cos 60, that is equal to 2 into sine 60. So now therefore root x into 1 by 2, that is equal to 2 into root 3 by 2. 2 will cancel, and we can say root x equal to 2 root 3. Now if we square both sides, then we'll get x equal to 4 3 is 12. So x equal to 12. So the value of x is 12. And here it is told a force on an object of mass 100 gram. Mass is 100 grams, so it is 0.1 kg. The force acting on it, that is equal to 10 I cap plus 5 j cap Newton. The position of that object at t equal to 2 second, the position of that object is ai cap plus b j cap meters after starting from rest. So this is x starting from rest. So x equal to ai cap, not x, it is r vector. R vector equal to ai cap plus bj cap, and it starts from rest. It means at t equal to 0, the initial velocity u vector, that is 0. The value of a by b has been asked. A by b value is how much? Force is acting and mass is this. So therefore we can find out the acceleration. Acceleration will be f by m. So this is 10 I cap plus 5 j cap divided by 0.1, this much meter per second square. So this will be 100 I cap plus 50 j cap meter per second square. And then this is acceleration vector. So r vector we can say that is equal to u vector into t plus half a vector into t square. Since why here acceleration is constant, t equal to 2 second we have to tell. So u is 0 only. So r vector we can say that is half into a vector into 2 square. So that is 2 to the 4. So that is equal to twice of vector a. Now therefore r vector, that is a I cap plus b j cap, that is equal to 2 times of vector a, that is 2 into 100 I cap plus 50 j cap. So from here we can say therefore a equals to 200 and b equals to 100. So therefore a by b that will be equal to 2. So the answer is 2. Okay. Then here it is told that a block of mass m slides on the wooden wedge, which in turn slides backward on the horizontal surface. The acceleration of the block with respect to the wedge is, even m is 8 kg, capital M is 16 kg. Assume all the surfaces shown in the figure to be frictionless. So here what is happening? All surfaces are frictionless. So if you draw the free body diagram of the mass m, so if the wedge is moving with some acceleration a1, then we can say on this mass m, some pseudo force is acting, which is ma, like this, and mg is acting downwards, and normal reaction is acting, and then surfaces are smooth. Now, so this is angle theta, and this is also angle theta. So then we can say that no, sorry, this will be angle theta, since this is angle theta. Okay, so this will be ma cos theta plus mg sin theta, and here we will have ma sin theta, and here we have mg cos theta. Now for the wedge, the free body diagram, if you draw, this is the normal reaction of the ground, let's say n1, this is mg, and here the normal reaction is acting n, and this is, it is moving with a1 acceleration. So therefore we can say n this way, this will be n cos theta, this is angle theta. So no, this will be angle theta. So this is n cos theta. Yeah. This is angle theta, this is 90 minus theta, this is theta. So this way we will have n cos theta, this way we will have n sin theta. N sin theta. So n sin theta, that is equal to mass into acceleration a1. And we can say n cos theta plus mg, that is equal to n1, which is not required. This one is required. And then here we can say ma so with respect to the wedge frame, with respect to the frame of the wedge, the block is not moving normal to the surface. So I can say it is in equilibrium. So therefore we can say that ma sin theta plus n, that is equal to mg cos theta. Therefore a1, we can say a1 ma1. So therefore n, that is equal to mg cos theta minus ma1 sin theta. So acceleration of the block with respect to the wedge. Acceleration of the block with respect to the wedge. Acceleration of the block with respect to the wedge, we can call it a2, suppose. So a2, that will be equal to obviously this force which is acting down the incline by the mass, which is a cos theta plus a1 cos theta plus g sin theta. This we have to find out. Okay, so now therefore n sin theta, n is equal to actually mg cos theta minus ma1 sin theta is n into sin theta, that is equal to ma1. So from here a1 we can find out, and a2 that has been asked. Okay, so here therefore we can say ma1 plus ma1 sine square theta, that is equal to mg sine theta cos theta. So therefore a1, that will be equal to mg sine theta cos theta divided by m sine square theta plus m. So therefore now a2, which we have to find, which is the acceleration of the block relative to the wedge, with respect to the wedge. So this will be mg sine theta cos theta, which is a1 cos theta plus g sine theta. Now this is equal to m, which is 8, m capital M is 16. So 8g sine theta sine 30 degree sine 30 cos 30 divided by m, that is small m, that is 8 sine square 30 plus 16. So this will be 8, we can cancel, 8 1 is 8, 8 2 is 16. It is g into half into root 3 by 2 divided by, this is sine square 30, that is 1 by 4 plus 1 plus 2. So this will be root 3g by 4, root 3g by 4 divided by 4 to the 8, 9 by 4. So this is root 3g by 9. This is a1. So this is root 3g by 9 into cos 30 degree plus g into sine 30 degree. So this will be root 3 g by 9 into root 3 by 2 plus g into sine 30, that is half. Okay. Okay, this is 9. 9. So this is 3, 3 is the 9. So this is g by 6 plus g by 2. Or I can say g by 6. So if you take LCM, this will be 6g plus 2, 3 is 6, 3g, that is 4g by 6. That is 2 to the 4, 2 3 is 6. So therefore the acceleration A2, that is 2g by 3. So it means the acceleration of the block relative to the wedge, that is 2g by 3. 2g by 3. So option D is the correct answer. Um, so here it is told that a car is moving on a plane inclined at 30° to the horizontal with an acceleration of 10 meter per second square parallel to the plane upward. So it is going upward with an acceleration 10 meter per second square. A bob is suspended by a string from the roof of the car. The angle in degrees which the string makes with the vertical is. So inside this car, there is one bob of a simple pendulum which is suspended. So the angle that the bob will make with the vertical is. G is 10 meter per second square. So here, as we can see, this is angle 30°. So this angle, this also will make an angle of 30° with the vertical. Now this line will make 30° with the vertical. This is the vertical line. Then here G is acting vertically downwards, and the pseudo force will act backwards. The pseudo force is acting like this, and the G is acting like this. Then we can take actually the components of G. This is the vertical line. This is 30°, and this is also so this will be G cos 30. This is G sin 30. So then so this is the tension force. We can say this is how much angle it makes with the vertical, this angle theta that is asked. So this is theta plus 30. So this weight is G. Then we can say what is happening inside the car. The line, this is the vertical. It is 30 degree. It makes an angle 30 degree. This way G is acting. This is the acceleration. So we can say if this is angle theta, then we can say that so we can find the component of acceleration along this. So this is theta plus 30. So this is angle 30. This is G cos 30. This is G sin 30. And we can say this will be actually T cos theta plus 30 degree. And this will be T sin theta plus 30 degree. So T sin theta plus 30 degree, that is equal to G cos 30 plus A. G sin 30 degree, that is G by 2 plus A. It means it is 15. And T cos 30 degree theta plus 30 degree, that is equal to G cos 30. That is G by G root 3 by 2. That is 5 root 3. Therefore, we can say that tan theta plus 30 degree, tan theta plus 30 degree, that will be equal to 15 by 5 root 3. So 5 3 is 15. So it is root 3. So theta plus 30 degree, that is equal to tan inverse root 3, which is 60 degree. So therefore, theta will be equal to 30 degree. So it makes an angle 30 degree with the vertical. So 30 degrees answer. And here it is told the coefficient of static friction between two blocks is 0.5 and the table is smooth. The coefficient of static friction in between the two blocks. Coefficient of static friction in between the two blocks is 0.5. Table is smooth. Maximum horizontal force that can be applied to move the blocks together is so maximum force that can be applied, that is equal to this will be F, and here frictional force will act, that is mu n. So that is mu into 10, mu into 10, that is 5 Newton, since mu is 0.5. So therefore, so if you draw the free body diagram of this 2 kg block, then it will be here F, and here the frictional force, that is 5 Newton. So 5 minus, and this is the acceleration. So 5 minus F minus 5, that is equal to ma 2 into a, and the 1 kg block which is placed above it, that is equal to 1 kg block which is placed above it, that is equal to this will be 5 Newton, which is the friction. 5 Newton, that is equal to MA, 1 into A. So therefore A equal to 5. Therefore F will be equal to 5 plus 2 into 5, that is 2 5 is 10, 10 plus 5, that is 15. So force is 15 Newton. So the maximum horizontal force that can be applied to move the blocks together is 15 Newton. A body of mass m is launched up on a rough inclined plane. Which is making an angle 30° with the horizontal. The coefficient of friction between the body and the plane is root x by 5. If the time of ascent is half the time of descent, then the value of x is. So the time of ascent, a body of mass m is launched on a rough inclined plane. With the coefficient of friction between the body and the plane is root x by 5 if the time of ascent is half the time of descent. The time of ascent is suppose t1, time of descent is suppose t2. T1 we have to find out. So here friction is acting is moved up with the initial velocity u. So time s, let's say the length is L. L equal to u into t1 minus half a1 into t1 square. Here it is told that time of ascent, that is t1, that is equal to half of the time of descent, half of t2. So then, and final velocity is 0 only, so I can say 0 equal to u minus a1 into t1. So u equal to a1 into t1. So we can write L, that will be equal to a1 into t1 square minus half a1 into t1 square. So that is equal to half a1 into t1 square. So acceleration while going up, the acceleration that we have to find, actually there is a retardation. So here g sine 30 is acting g by 2, and frictional force is also acting minus, so plus mu into g mu mg cos theta. So mu g cos theta. So g root 3 by 2. So here a1 that is equal to g by 2 into 1 plus root 3 mu. And a2 while it is coming down, then the acceleration, that is g sine theta, that is g by 2, that is a2 that is equal to g by 2 minus mu mg cos theta, that is mu g root 3 by 2. So A2 that will be equal to G by 2 into 1 minus root 3 mu. So therefore T1 square, that is coming L by that is 2L by A1. A1 is G by 2 into 1 plus root 3 mu T1 square. And similarly T2 square, similarly L I can tell that is equal to half into A2 into T2 square. So equal to half into G by 2 into 1 plus root 3, or so okay, T2 that will be equal to 2L by A2. T2 square that will be equal to 2L by A2. So T1 that is half of A2, so I can say T1 square that is equal to T2 square by 4. So T1 square that is equal to 2L by A1, that is, and T2 square that is equal to 2L by A2. Now T1 square that is equal to T2 square by 4. So 2L by 4A2. So 2L will get cancelled. So then I can say A1 equal to 4A2. A1 equal to 4A2. So therefore A1 that is equal to G by 2 1 plus root 3 mu equal to 4 into A2. A2 is G by 2 into 1 minus root 3 mu. G by 2 into 1 minus root 3 mu. G by 2 into 1. Okay, so therefore you can cancel G by 2 and G by 2. So then 1 plus root 3 mu that is equal to 4 minus 4 root 3 mu. Therefore 4 root 3 mu plus root 3 mu that is 5 root 3 mu that is equal to 4 minus 1 that is 3. Therefore mu that is equal to 3 by 5 root 3. So this is root 3 by 5. So that is equal to root x by 5. So therefore x equal to 3. So therefore x is, the value of x is 3. So here it is told that a bullet of mass 0.1 kg is fired on a wooden block. Bullet is fired, which is mass is 0.1 kg, to pierce through it, but it stops after moving a distance of 50 centimeter into it. So it moves through a distance of 0.5 meters and then it stops. If the velocity of the bullet before hitting the wood is 10 meter per second and it slows down with uniform deceleration, so uniform deceleration is there, then the magnitude of effective retarding force of the bullet is x on the bullet is x Newton. So x Newton is the effective retarding force. The value of x to the nearest integer is, so here as you can see, so we can say v square equal to u square plus 2as, where v is 0 when it uh, crosses a distance of 50 centimeters. So this is 0 square, that is equal to u square, u is 10 square, then minus 2a into s is 0.5. So therefore 0.5 into 2 is 1, so a equals to 100. So the retardation is 100 meter per second square, and therefore the effective retarding force that will be equal to mass into acceleration. So that is mass, that is 0.1 kg into 100, that is equal to 10 Newton. So therefore the value of x is 10. So 10 is the answer. Then here it is told a boy of mass 4 kg is standing on a piece of wood having mass 5 kg. If the coefficient of friction between the wood and the floor is 0.5 meter, no, sorry, it is 0.5, the maximum force that the boy can exert on the rope so that the piece of wood does not move from its place is. So here there is a frictional force. Here actually there is a frictional force. This is mu. Mu is equal to 0.5 and the mass of the wood, that is 5 kg, and mass of the boy m1, that is 4 kg. So therefore this is mu times n. This is the frictional force. This is the tension force. So if you draw the free body diagram of the block, then this will be the block is having mass, so weight is acting mg, and then the normal reaction force of the boy is also acting, that is we can call it r. Um, and then frictional force is there, mu n, and this is the normal reaction force, and here the tension force is acting. And if you draw the free body diagram of the boy, then he is being pulled by, so he is applying force. So the T is the reaction of that force. Tension force is acting, and then his weight is there, m1 into g, and the normal reaction is there, that is r. And in between his feet and the wood there is no friction, which is, since it has not been told, so we assume there is no friction. So now here we can say that r plus t, that is equal to m1g, and r plus n, that is equal to mg, and t equals to mu n. So therefore r plus t is m1g. So r plus t we can say that is equal to 40, r plus n, that is equal to 50. So if we subtract this, then we will get R equals to, I can tell this is 40 minus T. Or I can say R is 40 minus mu n. So 40 minus mu n plus n, that is equal to 50. So therefore I can say n into 1 minus mu, that is equal to 10. Therefore the normal reaction is 10 by 1 minus 0.5. That is 0.5. So that is equal to 20. N is 20, and therefore the force that he is applying on the rope, so F will be equal to T only. Therefore F, that is equal to T, that is equal to mu n. So which will be, so his applied force is mu, that is 0.5 into n, that is 20. So that is equal to 10 Newton. So 10 Newton is the force that he should apply on the wood, so that it does not move from its place. So here it is told that two blocks mass m, that is 0.5 kg, and mass capital M is 4.5 kg. They are arranged on a horizontal frictionless table as shown in the figure. The coefficient of static friction in between the blocks, this is 0.5 kg and this is 4.5 kg. And the coefficient of static friction in between the blocks, mu, that is 3 by 7. Then the maximum force that can be applied on the larger block so that the blocks move together is. So the table is frictionless. The table, it is frictionless, is smooth. So then therefore we can say that here frictional force is acting. So if we draw the free body diagram of the capital mass M, then here we have mg, here we have normal reaction N, and here we have F, and here we have frictional force Fr. Then the small m mass, it has got its weight is mg, the normal reaction is N1, and here also N1 is acting, and this is and here the frictional force, that is frictional force, will act. So now we can say that the blocks move together, is told. So this is moving with acceleration a, this is also moving with acceleration a. So then we can say F minus Fr, that is equal to ma, and F. Okay, so this is m into a, this is small mi. So now acceleration, that will be F by m plus m. So therefore the frictional force, that should be m F by m plus m. And this frictional force, that should be less than or equal to mu n1 actually. And here n1 will be equal to mg. So therefore mf by m plus m, that should be less than or equal to mu into n1, and n1 is mg. So therefore, m will cancel and f should be less than or equal to mu g into m plus m. So it means that the maximum horizontal force that can be applied on the larger block, that will be equal to mu is 3 by 7 and g, that is 9.8 into m plus m, that is 5. 7 1 is 7, 7 4 is 28, 27. So 3 into 7, that is equal to 21 Newton. So the maximum horizontal force that can be applied is 21 Newton. And here it is told body of mass 2 kg, mass is 2 kg, it moves under a force that is 2i cap plus 3j cap plus 5k cap Newton. It starts from rest. So u equal to 0 and was at the origin initially. So at time t equal to 0, it was x, r was equal to 0. R vector was 0 only. After 4 seconds, its coordinates are at t equal to 4 seconds. At t equal to 4 seconds, its coordinates are 8, comma b, comma 20. Then the value of b is. Okay. So it means that r vector at t equal to 4 seconds, that will be 8i cap plus bj cap plus 20k cap. The value of b is okay. So therefore, if we can say the force is a constant force, so acceleration also will be constant, mass into acceleration. So therefore, acceleration vector, that is f vector by m. So that is 1 by 2 into 2i cap plus 3j cap plus 5k cap, this much uh, meter per second square. So it will be I cap plus 3 by 2 j cap plus 5 by 2 k cap, this much meter per second square. And then therefore, as you know, s vector, that is equal to u vector into t plus half a vector into t square. Now here s vector, that is r vector minus r naught vector, that is 0 only. So r vector will be equal to u into t. So u is also 0. So it will be half a vector into t square. So now therefore, at t equal to 4 seconds, r vector, that is equal to half into acceleration vector, that is I cap plus 3 by 2 j cap plus 5 by 2 k cap, 5 by 2 k cap. So this is acceleration vector, this is acceleration vector. So half into a into t square. Now t square, that is 4 square, that is 4 square. R vector, that will be equal to half into 2, 8 is 16. So this will be 8 I cap plus 2 for the 8, 4 3 is 12 j cap plus 2 for the 8, 4 5 is 20 k cap. So this is equal to 8 I cap plus b j cap plus 20 k cap. It has been told. Yeah. So therefore, the value of b will be 12. The value of b is 12. So 12 is the correct answer. So here it is told that a person standing on a spring balance inside a stationary lift measures 60 kg. The weight of that person in the lift, if weight of that person if the lift descends with uniform downward acceleration of 1.8 meter per second square will be. So there is a lift. So inside the stationary lift, he is measuring his weight as 60 kg. So his weight, that will be equal to it measures 60 kg. So the spring balance, it will measure the normal reaction. Spring balance will measure the normal reaction. So this is normal reaction. This is mg. The mass is m. So the okay. So it is. So if it is stationary lift, then therefore I can say n will be equal to mg. The normal reaction is mg only. So therefore the normal reaction will be 60 into 10, that is 600 Newton. So therefore the actual mass of that person also is 60 kg. So now if the lift descends with uniform downward acceleration of 1.8 meter per second square, then what will be the weight of that person? Weight of that person will be how much? It means how much will be the apparent weight, means the normal reaction which is exerted by the floor of the lift. The normal reaction which is exerted by the floor of the lift. So then here you can say that mg minus n, that will be equal to mass into acceleration. So then the normal reaction will come m into g minus a, which will be the apparent weight. So mass is 60 kg into g is 10 minus acceleration, that is 1.8. This will be 60 into 10 minus 1.8, which is 8.2. 60 into 8.2, that is equal to 6. 8.2, so it is 6 into 82. So this will be 6 to the 12, 6 to the 48, 492 Newton. So 492 Newton is the weight of the person if the lift descends with uniform acceleration 1.8 meter per second square. And here it is told a boy pushes a box of mass. There is a box of mass 2 kg. Box of mass 2 kg. So here one force is applied. The force is given as 20 I cap plus 10 J cap Newton of a frictionless surface. Okay. If the box was initially at rest, then dash meter is the displacement along the x-axis after 10 seconds. It means that at t equal to 10 seconds, what will be the displacement that we have to find out? At t equal to 10 seconds, r magnitude of r is how much? Since why at t equal to 0 seconds, we can say, so Suppose we assume that at t equal to 0 seconds, the box was initially located at the origin only. So r dash, so r vector is 0, r initial we can tell. So now r final, that we have to, r final minus r initial, we have to find out actually, since the displacement vector is given as r final minus r initial. Now r initial is 0 only, and r final, that will be equal to half at square. So it is half at square. So half into A is force by mass. Mass is 2 kg. So therefore 20 by 2, that is 10 I cap, plus 10 by 5, that is 5 J cap. This much meter per second square. So here acceleration is 10 I cap plus 5 J cap into t square. T is 10, so 10 square. So this much meter. So this will be 2 5s are 10, 5 I cap plus 5 by 2 J cap into 100 meters. So this will be equal to 500 meter I cap plus 500 by 2 meter J cap. Therefore, the displacement vector, that is r final minus r initial, that will be equal to this 5 I cap plus 5 by 2 J cap into 100. So it is 500 and this is 500. This is 500 I cap plus 250 J cap. So how much is the displacement along the x-axis only, it has been asked. So that will be, so along x-axis, the displacement will be 500 only. Displacement is 500 meters. So option, so yeah, so 500 is the answer. And here it is told, as shown in the figure, a block of mass root 3 kg is kept on a horizontal rough surface on a friction coefficient 1 by 3 root 3. The crucial force to be applied on the vertical surface as shown at an angle 60 degree with horizontal such that it does not move will be 3x. The value of x will be. So here the force is applied at an angle. So now its weight is acting vertically downwards, which is mg. G is acting vertically downwards, and the coefficient of friction mu is 1 by 3 root 3. And here this force is acting. So therefore this is 60 degree. So it means this will be 30 degree. So therefore I can say this is F cos 30 degree and this is F sin 60 degree. Now the maximum force that can be applied, so F max, that is 3x. So then x you have to find out. So now since the block is in equilibrium, the if the block is in equilibrium, then I can say the net downward force was okay. So the frictional force will act here, mu n. Here normal force will also act. Mu n will act towards the right, since why F sine 60 is acting towards the left. So therefore I can say F sine 60, that should be equal to to F sine 60, that is equal to mu n, and F cos 30, sorry, this is F sine 30. F sine 30 equal to mu n, and then F cos 30 plus mg, that is equal to n. Now mass is √3. Okay, so therefore I can say F sine 30, that is equal to mu into F cos 30 plus mg. Oh, yeah, so n is F cos 30 plus mg. So then from here we can say that F sine 30, that is F by 2 minus mu F √3 by 2, that is equal to mu mg. From here F by 2 I can take as common, so F by 2 into 1 minus √3 mu, that is equal to by 2 into 1 minus √3 mu, that is equal to mu mg. Therefore F will be equal to 2 mu into √3 m 3g. M is √3, it has been told. 2 mu √3g divided by 1 minus √3 mu. So this will be 2 into mu is 1 by 3 √3. 1 by 3 √3 into √3g divided by 1 minus √3 into mu, that is 1 by 3 √3. So this will be equal to √3, √3 will cancel, √3, √3 will cancel. So this is 2 by 3 by 1 minus 1 by 3, that is also 2 by 3. So into g, that is equal to g only. So F equal to g. So F will be equal to 3x, that is equal to g, that is 10. So x will be nearly about 3.3. F cos 30 plus mg, that is equal to n. So x will be like 3.3 3.33 approx. Then here it is told an inclined plane is bent in such a way that the vertical cross section is given by y equal to x square by 4. Y equal to x square by 4. Y equal to x square by 4 is somewhat like this. An inclined plane is bent in such a way that the vertical cross section is given by y equal to x square by 4, where y is vertical and x is along horizontal direction. The upper surface of this curved plane is rough with friction coefficient 0.5. The maximum height in centimeter at which a stationary block will not slip downwards is. So the height at which it will not slip downwards. The height we have to calculate from this level. This is the height. So at this height, the angle that is theta, this angle is theta, is y equal to x square by 4. Now this is x-axis, this is the y-axis. So this is the origin. Now this height we have to find out. So y equal to x square by 4. If this is theta, then this way it will be mg sine theta. And this way it will be mu mg cos theta. Since y here mg cos theta is acting, and here there is normal reaction. So if mg sine theta that is equal to mu mg cos theta, then it will not slip downwards. Then only we will get the maximum height. So here, so let's say this point is x comma y, then actually height is the y coordinate of this point. So this only has been asked. Okay, so then mg will cancel. So tan theta will be equal to mu. So tan theta we can say that is equal to okay, that is dy by dx. Dy by dx that will be equal to 2x by 4. That is equal to x by 2. So now x by 2 value that should be equal to mu. That is equal to, so therefore x will be equal to 2 mu, that is equal to 2 into 0.5, that is equal to 1. So x is 1, therefore the height that is equal to the y coordinate of that point, that is equal to x square by 4. So which will be 1 square by 4, which is 1 by 4 meters. So 1 by 4 meters will come. So it means that is 100 by 4 centimeter, that is 25 centimeter. So 25 centimeter is the correct answer. Then here it is told that the coefficient of static friction in between a wooden block of mass 0.5 kg and a vertical rough wall. So there is a wooden block, and here we have a rough wall. We have a rough wall. and the coefficient of static friction, that is mu. The magnitude of horizontal force that should be applied on the block. So some force should be applied horizontally on this block to keep it adhered to the wall will be. So here mg is acting vertically downwards, and so frictional force will act vertically upwards, which is mu times n, and here there is normal reaction. So the block should remain at rest only in the on the wall. So therefore I can say the net force towards in the horizontal should be 0, and net force along vertical also should be 0. So therefore n will be equal to F, and we can say mg will be equal to mu n. And here mu has been given as 0.2, and the mass is given as 0.5 kg, and g is equal to 10 meter per second square. Therefore mg m is 0.5 into 10, that is equal to mu, that is 0.2 into n, that is F. So F we have to find out. So 0.5 into 10, that is 5 equal to 0.2 into F. So F will be equal to 5 by 0.2, so 2 by 10. So this is equal to 50 by 2. That is F will be equal to 25 Newton. So 25 Newton is the correct answer. So hope all of you understood the solutions of all these questions based on the previous year JEE Mains exam on the chapter laws of motion. Still any doubts if you have, please write that in the comments. We shall obviously clarify them in the subsequent videos. Also, please install our Sapience Education application, where we shall upload some important homework questions based on the previous year JEE Mains exam, which shall be obviously helpful for your exam. So thank you.